Welcome again, guys, to another one of my mathematics tutorials. In this session, we will be looking at how to complete the square. What is completing the square? It is a method used to solve a quadratic equation. Now, before we learn this method, we need to understand or recognize what is meant by a complete square or a perfect square as it pertains to quadratic equations. Now have a look at each one of these four quadratic equations. They are actually said to be perfect square trinomials, simply because we can write each of these as this. Now let's test one and see if this is indeed true. Let's test this one. So we say x plus 1 squared is going to be x plus 1 multiplied by x plus 1. Now to expand it out, we take our first term and multiply that by our second bracket, then our remaining term and multiply it by our second bracket. So we get here x squared plus 1x plus 1x plus 1. So this can simplify to x squared plus 2x plus 1. So yes, it is indeed correct. So we can write each one of these quadratics, and now we know that these are called perfect square trinomials because they can be written as perfect squares. Now, why do we need to know how to complete the square? Yes, it is simply another method used to solve quadratic equations. However, in some instances, it is very difficult to factorize a quadratic equation, and this is where completing the square comes into play. Let's have a look at a quadratic equation. Now, let's say we have the quadratic equation x squared plus 3x plus 2. This is what it looks like when it is factorized. Easy, right? I list A, B, and C. I multiply A by C. I find those two numbers such that when multiplied gives me back 2, and when added gives me that middle term. I replace that middle term with those two terms, and then I proceed to factorize. But what is going to happen if we have a quadratic expression that looks like this? Let's try to factorize. I have A being 1, B being 6, and C being negative 13. A multiplied by C is going to give negative 13. Factors of negative 13 are 1 and negative 13, negative 1 and 13. Now, neither of these pairs are going to result in 6 when added. So we cannot do this method. Now, what we will do is take that same quadratic expression and complete the square. Now, the aim is to form a perfect square somewhere along the line. So let's examine x squared plus 6x take away 13. This part looks familiar. Remember when we had x squared plus 6x plus 9, this could have been written as x plus 3 squared. So what can be done is we can write x plus 3 squared, and remember x plus 3 squared is going to give us this here. Remember, we only want x squared plus 6. We do not want this additional plus 9. So what we can do is from this we can take out that 9. And this here should result in x squared plus 6. So now, after writing this, we can simply put back this part. Take away 13. Now we can simplify x squared plus 3 squared. Negative 9 take away 13 is negative 22. Now this here is in the form ax plus h squared plus k, where this form is the result of completing the square, and in this case a is that number in front here and it's understood to be 1, h is positive 3, and k in this case is negative 22. Now, how can we easily determine what that square or perfect square is to put here? Let's look back at our quadratic expressions. Now, after examining each one of these quadratic expressions, it can be noted that if we look at our middle term, in each one of these, we can see that in order to derive these, it is simply to find half. Let's see. Half of 6 is going to give us 3, half of 2, 1, half of 14, 7, and half of 12, 6. So you can see that in order to find that term there, we simply have to find half of our middle term. Now, back to our question. So to get this term here, we understand that we simply need to find half of our middle term. Now, how are we going to determine what needs to be subtracted in order to remain with this part here? I simply square this term here. So to determine what needs to be subtracted, all I need to do is square whatever you have written here. Let's take a look at another example. Now, let's examine this part. We know that x squared plus 8x plus 16 is x plus 4 squared. So, this part here can be written as x plus 4 squared take away 16. We will not want this 16 here. We just want this part. So we can just take away 16 from it. And I can put back my plus 5. Remember, to find this, we could have done half of this term. And to figure out what we need to subtract, we simply square this term. So that is why we have take away 16 here. So to simplify, we get x plus 4 squared. Negative 16 plus 5 is going to give us negative 11. This is written in the form a multiplied by x plus h squared plus k. Anytime we complete the square, it is always written in this form, where a in this case is 1, h is 4, and k is negative 11. Now let's look at one more question. Now let's say we have 2x squared plus 20x plus 8. Now this is a bit different because we have a coefficient of x squared. So how are we going to determine what square is going to form this part here? What you can do, or what needs to be done actually, is to factor out that coefficient. So we divide the entire expression by 2. So we get 2x squared plus 10x plus 4. Now we can determine our perfect square with this. It's going to be x plus 5 squared. Remember, x plus 5 squared is actually going to give us x squared plus 10x plus 25. And we don't want 25, so we need to take away 25 from it in order to remain with just this part. So we have taken away 25 and now we put back our plus 4. We simplify, we leave that 2 outside there until the end. So we get x plus 5 squared negative 25 plus 4 is negative 21. And lastly, we multiply this 2 back by this and then by this. So we get 2 multiplied by x plus 5 squared, and 2 multiplied by negative 21 gives us negative 42. Now this is in the form a multiplied by x plus h squared plus k, where a is 2, h is 5, and k is negative 42. Now, how can we use this to solve a quadratic equation? So let's take this same expression and turn it into an equation. So I have 2x squared plus 20x plus 8 equals 0. And we have completed the square, so we know that this is actually equal to 2 multiplied by x plus 5 squared, take away 42. And we can now put this equal to 0. Now you can see it is easy to solve. I can take negative 42 across on this side and I get 2 multiplied by x plus 5 squared is equal to 42. Then our 2 goes across. It's being multiplied on this side, so it's going to be divided on that side. It's going to be x plus 5 squared is equal to 42 divided by 2 to give us 21. X plus 5 squared is equal to 21. To get rid of that squared, we need to find the square root. So I'm going to put square root of 21, and then we are going to carry that 5 across on that side. It's going to be x is equal to the square root of 21 take away 5. Now don't forget, when we find the square root of a number, it is both positive and negative numbers. So we will get two solutions when we work out the square root of 21. One will be negative, one will be positive, and then we take each and we deduct 5 from it. And that is going to give you two solutions for x. And there you have it, using completing the square to solve a quadratic equation.
Don't forget to like, share and subscribe for more of my videos.